Scott wants to swim directly across a river that is 400 meters wide. He begins swimming perpendicular to the shore, but ends up 100 meters down the river because of the current. How far did he actually swim from his starting point? Round to the nearest tenth if necessary. So the best thing to do to answer this question is first draw a diagram and see what we're talking about. So first we have Scott, and he's swimming, and he now wants to cross a river that is 400 meters wide, or 400 meters across. So he starts swimming, but the current is pulling him, so he's going to actually, when he swims, he's going to end up not directly across the shore, but 100 meters away down the river because of that current. So we want to know how far he actually swam, so that would be this length here. And we can see we formed a right triangle with the given information, and we're trying to solve for the hypotenuse to side across from the right angle that was formed with the river, how wide it was, with how far away down the river he ended up because of the current. So since we're solving for the hypotenuse given two legs, we can use the Pythagorean theorem. We can use a squared plus b squared equals c squared, where a and b are those two given values. Those are the legs of the right triangle, and c is now our unknown value of x, the hypotenuse. So a we'll say is 400, so 400 squared plus 100 squared equals c squared. 400 squared is 160,000, and 100 squared is 10,000. So now that equals c squared. So if we add 160,000 plus 10,000, we get 170,000. And solving for c, we'll take the square root of both sides and approximate that c, rounding to the nearest tenth, is 412.3. So if that's the value of c, that's our value of x. That's our hypotenuse. That's our unknown value of how far he actually swam from the starting point. So he swam 412.3 meters, making our answer choice A.